It's all yours.
Okay. Hi, everybody. I'm delighted to be here. Oh, yeah, you're changing it. Okay.
Do you want to change them?
Can
You
I?
can do it too.
Oh, yeah, sure. I want.
Here's a pointer.
Uh-huh.
Right there.
Oh, I'll keep my
There's a green pointer, and don't push the bottom one or it'll go blank on it. And turn it off.
I'm shaking hands as seniors. Okay. Well, thank you. I've been working on this biography for, I would say, well over 20 years. And I'm delighted to be here and to give you a chance to be exposed to a short summary of the book, which is available to all, open source, but I prefer it, of course, if I could sign the book for you. Okay. Now, which this is the one on the right. See, the green one is
The laser pointer.
good. Okay. And okay, but I want to change slides, so I just go
On the right arrow.
Okay. I'll explain that later. Well, George Carruthers was born in 1939 and in Cincinnati, and his father, also George, with George Archer Carruthers, was a civil engineer working at Wright-Patterson Air Force Base, and he just loved to build things, mainly fixing things. And and his mother also was a librarian at the University of Illinois. They're both fully educated, almost a middle-class environment. And the family in Chicago was very active socially. So he comes from that kind of family. The father, however, wanted to do everything he could to get out of town. And he remembered family outings in the summer to a farm, and he wanted to live on a farm. And so he moved the family to a small town called Milford. And there it is. I only show a few images of it, but there were several chicken coops. There were all sorts of other things, and he had to restore the farm. And George, by the time George was, this is later than these pictures, at least 12, 13, he would help his dad. His dad would show him how to use tools, which is a very important part of this story. Now, George was also fascinated by space travel and, things like Buck Rogers and things like that. He would read these things in the Milford library, but he also wanted a telescope. And here's the first picture, and really the only picture of George with a telescope. But if you look at it carefully, it's not a telescope, it's a soda bottle. And he was just looking to the sky with a soda bottle. And I want to thank Alan Janis, a dear friend of ours, who did AI on that image. You would not have been able to see him without, because the print that I got from his brother, Gerald, was just so ground up and everything, but reconstructed it beautifully. So at the upper right, we see George is in the middle, and Gerald is on the left, and Tony on the right. George is the oldest by about a year or two. And they're sitting on the family truck, and he really was very serious about not so much full farming, but they did have some, I think, goats, and they definitely had a lot of chickens. But it was more not for selling them. It was basically a thing that they would trade back and forth with people in the Milford area. And that, of course, is his mom with George. Very sadly, George's father died suddenly in 1952, and the mother could not maintain the farm. I mean, George's father was working at Wright-Pat, and he was making a pretty good salary, but then he dies unexpectedly, and the mother is left with everything, and she has to sell the farm. She can't maintain it, and they moved back to her mother's family in Chicago. On the south side. Well, that was quite a change, but it really worked out for George, as you can see here. He immediately, he was about 13 now, and he was able to get around on his own. And he immediately attached himself to the Adler Planetarium. They lived on the south side, so it wasn't too far from Adler. And at the Adler's building, mirror building classes, and I don't know if you've ever seen them at the Adler, they're really quite something. He built, the only thing that he could afford, or his mother could afford, was a 4¼ mirror kit. And so he built a Newtonian, his first real telescope. No, his second real telescope. I forgot to say that his dad, when they were still on the farm, bought him what I think are lenses and a mirror, just not a mirror, but two lenses, one for objective and one for eyepiece. And his dad helped him. George put it together in the tube and everything to be observed. I really would love to have seen an image of that. And also the image of the 4¼ Newtonian that he built at the Adler and also at home. But no pictures have been found, sadly. But those courses are really very, very stimulating to George. And he made a lot of contacts there. And he did pretty well in high school. He got into University of Illinois. Let me just make sure I'm here. Yeah, he continued his passion for rocketry, but his thesis, by the time he was a grad student, also at Illinois, was in plasma physics. And he got fascinated with plasmas actually in high school, but I have very little data on it. His one recollection from his younger brother was that they were always worried about George going to explode something. And I don't know if I have it here, but in his graduation from high school, he wrote a hilarious poem on blowing things up. And so he's an interesting character. Now, what we see here is in his mother's basement working on a plasma motor. He was very interested in interplanetary travel, and he was trying to develop a plasma motor, which he did more in college. And there are images of him experimenting. Well, he saw a poster on outside of his school lab one day for the Naval Research Laboratory. And he already knew about the Naval Research Laboratory and was fascinated. He also had heard a talk by Milton Rose from NRL and was very, very inspiring. And so with his thesis advisor's approval, George applied for a postdoc at NRL, and they had recently established a postdoc program, the E.O. Hulbert postdoc program. Hulbert was the founder of the science side of NRL. And they were very happy to take him, and they also offered, since he wasn't finished with his thesis yet, they offered to bring his thesis advisor with him to start their, finish their work at NRL. Well, both he and his thesis advisor decided, no, they'll stay in Illinois, and then got his thesis pretty quickly on plasma work, and also on what you can do with a plasma, not only interplanetary propulsion, but the reentry vehicles, survival of the reentry vehicle into the Earth's atmosphere. And no matter, that's sort of things NRL was interested in. Anyway, he was, and you can see NRL in the upper left, it's local to us, of course. And he got into the group headed by Herbert Friedman, who by then was probably the best known space scientist doing X-ray. He really didn't quite found X-ray astronomy, but he certainly was one of the first. And I have to qualify that because people get angry about geocoding. But Friedman was the first to do it in the 1940s, developing small chambers that's not an X-ray chamber. That's an ultraviolet chamber because you can see the anode through the window there. And he was developing them over the years, flying them all over the place on sounding rockets. And when George arrived there as a postdoc, he was given an assignment, and it was to improve on Friedman's detectors. That's a very interesting thing to be given to a student like that. But they knew that he was, by that time, really interested in plasma physics and the applications of plasma physics. And indeed, he started coming up with all sorts of fancy devices, not so much for point source work, which is what Friedman's did, but for area imaging. And that's a huge difference. Now, there were electronographic detectors that could manage, that could photograph area. The Lallemande tube from the 1930s into the 50s, the Krone tube, the Guy tube from England, and they were wonderful, but they were absolutely impossible to use. They were very cantankerous. In order to use the Lallemande camera, you take an exposure and then you have to break the glass in the tube in order to get the film out. It's just kind of nuts. And they were looking for something that was a little more reliable. Now, I know that personally because I worked at the observatory, and Merle Walker there was using Lallemande work, and I was basically the night observer and night assistant responsible for the 36-inch telescope. And Merle Walker, on a number of occasions, brought his Lallemande in to test it from the 36-inch because the telescope time on a 36-inch wasn't that extensive. And I watched him, and he and his assistants had horrible time. I don't think they ever made it work in 2 or 3 nights. So it wasn't a very practical thing for astronomy, and it certainly wouldn't go into a rocket, a missile, or a satellite. So that was George's first assignment, to improve electronographic designs. That's Kurt Friedman on the left, and they're looking at a Araby era instrument that George designed and built, and it's in the configuration of being a spectrograph. Those two plates are grating, and because they had to have a 4-square grating because they couldn't afford a full grating, and they needed area, so they made it that way. Now let's get into that. What did George invent, so to speak, or develop? And I mentioned it's electronographic image tube. So it uses it converts visible light into electrons, a beam of electrons, and then it magnifies that beam, and then it focuses that beam onto electron-sensitive film. This is one of the designs he built. This is his Cassegrain. You're familiar with Cassegrains. And so you can see the incoming light mirror goes to the photocathode, but the photocathode is not a mirror. It's a cesium iodide coated, but still convex surface. And then the focusing magnet carries the electron beam, electron image through the Cassegrain hole, and there is a cassette, film cassette, which is filled with this electron-sensitive film. So this is for direct imaging, and it's relatively wide field. No, this is the Cassegrain, because it's used for spectroscopy. I'll get to that in a minute. The other design he had was for spectroscopy, and it's a Schmidt. It's a Schmidt camera. The light comes, hits the grating, a big grating, and then the grating sends the spectrum into the Schmidt through a lithium fluoride window, which is what Schmidt uses to correct things, to the mirror, and then eventually to actually another mirror, but to the film transport. The diagram isn't too good, but the big mirror sends the light to the annular portion, the large portion of the secondary, and then it goes to tertiary, which is where the detector, and that sends the electrons into the film transport. This was a little harder to come by and make it work right, but George did a very quick job and had his first major discovery with it. Here's George, and you can see it's small, it's compact, and it turned out to be quite rugged, except that it was a variation. You can see the magnetic cylinder there, and there were various different designs for that and how it would be powered. And some of them had weight issues, and you would go back and forth with those. But that's basically what he invented and built. Since it's calcified, I have no idea how many, because it was used for all sorts of purposes. At the same time, with his PhD and a real job, he married Sandra. There you can see them. And these are the three brothers, finally all married. George was the last one. George was the oldest brother, but he was the last to get married. And I have to say that Gerald, there, and he is George. Gerald is in the back there. Was extremely helpful for me. It just absolutely. He submitted to oral history stuff. He provided me with in the photos. Most of the photos I have are from Gerald, and he's still bumping along in Huntsville, Alabama. And I could talk about him for quite a while, but I won't. Okay, well, what did George do with that detector? He took the spectroscopic gas version, and he put it on a Araby rocket. And what you see there on the left is a standard lamp that was used to calibrate the thing. And the instrument is inside the Araby tube. Nose cone has all of the various electronics that are needed to manage it. And he field tested it there and had several flights. And one of them, the one that really worked well, was one that went down in the record books. He confirmed that there's an enormous amount of molecular hydrogen in space, and that is what was needed to make stars. And this had been hypothesized, of course, and back and forth the observations were indicative, but he actually not only was able to determine it and defend it definitely, but also get an estimate of the abundances. And I won't go into detail because it's too much physics for me. The citations were very good. They dropped off quickly because they were, and I don't know if you know, his professional paper on it, the one in the upper left, this tells you how many times it was cited by others. And at that time, in the early 70s, 50 was good. Blue is referee, green is not. So then this came from this astrophysics data system. You're probably familiar with that. It really made a name for George. Your local group, the National Capital Astronomers, and I hope to speak to them eventually, brought him into to be a speaker, and with an image of him with the payload and a version of the Araby in the back. The irony is, and of course George was not sensitive to this at all, but the National Capital Astronomers did not allow any minorities as members. They had just changed that rule maybe, I don't know what, maybe a year or so before George gave the talk. The people I've talked to there are, saying, well, that was the way the world was, and I'm afraid they're right. So he gained this notoriety, and I now want to turn over the podium to George, because before I let him speak, the issue was he made enough notoriety so that his next goal, and plenty of people were supportive of it, was Apollo, and to put one of his instruments on Apollo. Now, why is that important? Because this is a photographic device, and it requires physical retrieval of the data. It can't be telemetry, at least not at that time. It couldn't be. And so sounding rockets worked, and if it was, space, it had to be retrieved. And the Apollo certainly was a retrievable one. The earlier ones would have, but it was far too. It was a little late for George. This is getting into the 60s and late 60s, and George was still developing his detectors and trying to decide what the best one was for. But anyway, he also signed up for. There was an opening. There was an advertisement for astronauts and general, and that's, I have to get it right. They were instrument. They flew to manage the scientific instruments. That's what NASA wanted. They did not want people who flew specific instruments, their own. They wanted somebody who would keep people who would keep all of the instruments healthy. Well, George applied for that, and he didn't get it, not because he was only thinking about his own payload, which was a concern, but it wasn't the deciding concern. The deciding concern was his eyesight. He was wall-eyed, and pretty severely. You can see it in some of the pictures. But he claimed he could do it with one eye. I mean, he was a little, I'm sure he was upset, but he was denied that. And so he did not become an astronaut, but he did get the berth on the Apollo spaceflight. Now, this wasn't easy because there was competition. What George was, specializing in was imaging in the ultraviolet, and there were others who were proposing that. And Thornton Page, I don't know if you know that name, he was one of them. And I want you to listen to George about what he knew at the time about the competition with Thornton Page. Ignore my talking, I couldn't clip this out. In the camera. I didn't know at the time. Well, there's Thornton Page. I knew him quite well. When he took a sabbatical at UCLA, I was nominated, or I was designated to be his gopher. And he was the kind of guy who really had fun using the gopher to do everything, including picking up his weekly check. And I couldn't forge his name, so I had to give it to him. But he was an elitist, to be sure, and also very, very influential. Here you can see him with Carl Sagan, and of course, as you probably know, it's all about UFOs. And George had a particular position, I won't go into it, as a professor at Wesleyan. And he was probably one of the best known people speaking publicly other than Carl Sagan on flying saucers. But in '69, he proposed the celestial imaging of the moon, and he was planning to use Carruthers instruments, but in fact, he didn't tell Carruthers at first. Page was on the committee, the NASA committee, that was making the choice. George Thornton Page was very influential, and he said, well, I mean, I don't know what he said, but he got a pretty good rating for his proposal. His own proposal, I'm not sure if I had it. No, I'm sorry, I don't. It's actually quite hilarious. It's like a 16-inch Herschelian on a albazimuth mount that wouldn't fit into the Apollo carrier. And he had all sorts of expectations on it, and it was to be operated remotely from Earth. And it got very low scores. But his proposal for using Carruthers' camera got very high scores, but so did Carruthers get very high scores. And basically they were people. Well, you know what NASA does, it puts them together, and that's what happened. And actually this worked out very well for George, because George, his personality he was very shy, he was very quiet. And there's a book about quiet scientists who invent things. I can't remember the author, but it's a wonderful book. And it's in the book, I reference her. I think it was a very good match, because Thornton was all about contact. He was all about being the spokesman. He knew how to convince people how to do things. And George would just stay away from all of that, and he did not have to worry about it. So Thornton did, a good service. Okay. Well, this is the camera that George came up with, and what is inventive about it is it's two telescopes in one. You can see it's this golden configuration, and from the side, though, you can tell better how it works. The camera itself, there's only one camera here. Let me try to stabilize this. Here's the camera here on a pivot platform. There's the film cassette. Now, when it's pointing in this direction, it's just direct imaging. But if you turn the camera 90 degrees, turn the camera 90 degrees, it will get the light from a grating that had been sent through a collimator. That produced the spectrum. So all the astronauts had to do, carrying this thing to the moon, other than setting it up, which is a story in itself, but it was far, 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 far easier. It wasn't George's fault that it was hard to set up. And I'll say a few things about that. What the astronauts had to do was turn it back and forth according to orders, and all of the exposures were done automated, timed with a timer. And let's see, what do I have next? Yeah, there was a little problem with the Apollo orbiter and during the Apollo flight. Let me make sure I have it right here. There was a delay of 6 hours landing. They were in lunar orbit, and then the next step, of course, was the lander and the service module to separate from the Apollo craft. And that separation didn't work very well. There was a gyroscopic problem and stuff like that. And it took them about 6 hours to fix it. Well, the moon does rotate. It doesn't rotate too much in 6 hours, but it's enough if you're looking at it with a telescope and trying to get a specific field, is that you have to adjust it. And this was the schematic of the field, telescope field, and you can see all of the objects that they wanted to observe, and this would not only the Earth, but the galaxies and star-forming regions, nebulae. George was still interested in the H2 problem, but what's his name? Thornton was adamant about it. That was his primary fascination. So they had to recalculate in Houston during this time. I mean, the craft was in lunar orbit. George was there, and in the spacecraft center, and he was told of the problem, and he immediately set up a course of recalculating where all of these objects would be, which he and Thornton Page did. They were both capable quite easily to do it, but it was a lot of numbers. And I asked George, and he said, yeah, we had to do it by hand. That's crazy. But anyway, that was done. And then finally, the craft was, something happened here. Well, forget my attempts at animation. The blue spot there, I don't know what the yellow one is doing there. I erased it at one point. The blue spot is the landing site for Apollo, and that is the Descartes uplands. It was in the Highlands, one of the first, I don't know if it's the first, but very early landing in the Highlands, out in the Mare and stuff like that. And the landing worked perfectly. There was no problem. Of course, there was the cooling off period. But there they are. That's John Young, Thomas Mattingly, Charles Duke. Young was the one who was with managing Carruthers' camera. And I tell you, the data back and forth, NASA has it's all online. You can get the transcripts, and it's hilarious. Mm-hmm. At one point, John Young takes the camera out, and he says, "Look, I'm lifting it. I'm lifting it." 6G. Well, it's possible. And there were many other things. There was also the problem of tripping over things. But let's not get into that. Okay, here it is in the shadow, of course. Now it had to be in the shadow because it was trying to see, all these nebulae and everything like that. Didn't have to be in the shadow for the Earth, but they kept it in the shadow because of the temperature problems. And there it is. There's only one funny thing about this picture. Anybody know what it is? You can see the camera when it's in shadow. And NASA doctored the picture. Okay. Or maybe they had some guy up there, a photographer with a flash. Yeah. I mean, I love the footprints and all of that. One of my favorite pictures, but it is doctored, and I can't get anybody to remember or know that it was doctored. I just, but I can't help having fun with it. I didn't say anything about it in the book. Okay, well, what he found? The astronauts had to keep the camera happy. There was only one strip of film. It was quite a few meters long, and so there were quite a few exposures that were timed, automatically timed. But there were sequences that were taken through one or three filters that the astronauts had to change in the camera. That was their total involvement. There was more than that. Now you can see in the visual, the infrared, and the ultraviolet. I mean, they're all ultraviolet, but they're one is on the visual side. That the geocorona of the Earth, these are aurora that you can see, are quite different size, which did not surprise anybody. But their extent and their nature and their dependence on solar. What is it? When the sun sneezes, the Earth catches a cold. But then NASA, if I just do it, there you go. NASA put them together in a colorized version, and those are the three filters, but colorized. All of them are invisible to us, and that is what is on our book. My book. Whoop, sorry about that. And it's also the one that was really touted popularly, even though it was not a scientific in the display. In fact, the actual data did not come only from these photographs, but for other sensors that went far, far beyond them, their visibility, because they knew they were trying to gauge the extent of the geocorona. And that's a big reason why they went to the moon, because it was thought to be beyond the geocorona. None of the Earth satellites were beyond the geocorona. So that's it. George, of course, gained a lot of notoriety for this. It got bigger and bigger as things moved on. But he also started getting, not fascinated, but he felt obligated to give back, which was his term, to give back to society, because he felt society had done him well, not perfect, but he was not. When I asked him questions about, inner city issues in Washington and all of the racial horrible things that are going on, he was, as the book, a quiet book says, people like him, he was immune. He was not personally affected. He didn't have children, and he was never expressed any concern about it. He certainly, I'm sure, didn't like it, but it did not bother him at all. It did not change his life. So he turned to mentoring about that time, and here's a few scenes of it. Some very interesting ones. This is at Howard, and what George did, he found an old telescope at Howard. There was an observatory there, I think. Now, I've never been there, and it wasn't working. Nothing was working, and he fixed it. He made it. He had the students work with him to fix it, and there they are having fun at various. They would on various times transits, issues of things that were interesting to watch. This is a solar one that another telescope that they made under his direction. See, he did not make things himself. He would help kids, not kids, but high school and early college kids, realize that they can do it for themselves. That was the key to his mentoring. I mean, yes, he lectured off and on, but boy, all of the time was mentoring in his lab, in their labs. It was really very, very different, but it was very well received. I think this one is a transit of Venus image at Howard. Okay. He also became active in the various societies, Black Science, and helped them get better organized, actually. The ones that were local, like well, I don't have to go through them all, but they were pretty poorly organized, and he was an extremely good organizer, and he did it. So he helped in many ways. Okay, well, as you may know, NASA periodically does a cordon of its junk, and the Smithsonian, for stuff in the sciences anyway, has been getting first dibs. And that was a very interesting procedure. Now, I was a beneficiary of that when I was hired in 1981, but the process was hilarious. I mean, nobody knew what it was they were getting rid of. And we'd get a big pile. Well, I don't have the picture here, unfortunately, but NASA had several versions of the camera and backups, basically. One went to Houston, and then two of them came to the museum. One was just basically a mock-up, but the other was actually a backup. And it just arrived in a box, completely dismantled. I wish I included, I don't think I included the picture. But anyway, George helped us connect it all together. That's when I started meeting George and appreciating, his kindness and his willingness to mentor me too. And here's a picture from a video history I took at another stage of refurbishing the telescope of the camera. What did he do? You see this little thing? See, that's the point of, yeah, this. That is the film cassette that the astronauts brought back from the moon. And George got NRL to agree to transfer it to the Smithsonian, and he integrated it into the camera that's on display. So we have something that, or they have, because I'm not there anymore, that is absolutely, beyond belief. It's wonderful. And I led a crew doing video history in the early 90s, and this is one of the images from it, one of his mentees. Oh, that's the wrong button. Okay. Here's another one. Oh, that's me to prove it. And his wonderful student was behind him, and he's putting it together and he's demonstrating it. We have videos of the demonstrations and stuff. There's plenty of those. Now, the camera was displayed first under the lander, which was, appropriate, at the Air and Space Museum. And then, as another gallery opened, reopened, it was put there in a case, in a glass case, for safety. Well, one of the conservators, they periodically open the cases and see how the thing's doing. And she opened up the case, and it was a smell. What's that smell? I think I say that here. No, I missed. Oh yeah, what's that smell? Sorry. They figured it has to be if there's film in the camera and it's been this long, the film might have been disintegrating and stink. There was some kind of chemical reaction. So they took the camera out, and from NRL, Seeley, Bob Seeley, Ted Seeley, what? Tom. Yeah. Oh, it says Tom. Yes, of course. I wrote it down for that reason. Robin O'Hearn, she's a conservator at the museum. I can't remember the guy's name on the left. He was there. They had the smell, and they identified it as methyl ethyl ketone, or something like cough drops, and it smelled like a dentist office, she said. So they had to clean it, they had to restore it, but there was no film in it. There was only the residue, and there was a lot of rust. And so they fixed it all up, put it back together, and yeah, there's the image that shows that it was no film. And boy, was I disappointed. Okay, so there it is. I mean, it was first on the east end with the astronauts, then in the Apollo to the Moon gallery. You can see George there on a special occasion. I'll explain that in a minute. And then finally, it's now on display, back on display in the Destination Moon gallery, in context, on the moon with the rover, various other things there, and a much better label than I was allowed to do officially. They said no more than 2 or 3 sentences. Oh yeah, I mean, when it was in Space Hall, you couldn't have any longer essays and that sort of thing. And I wanted to write a book, which I finally did. So there it is. It's there now. You can go and enjoy it. And there's George looking at it when it was in Apollo to the Moon gallery. And this is an occasion, George's second marriage to Deborah Thomas. And they had not the marriage at the museum, but the reception at the museum. Yeah, we couldn't have marriages, right? I think I was one of the only people who was married at the Air and Space Museum in secret. I can tell you all of that. But anyway, there it is. Very proud to have it. And as you know, I mean, he won many, many awards, and culminating in the National Medal of Technology and Innovation in 2013. I, of course, looked for the records of this. I had the names of the committee, and I tried to contact some of them. No answer. But somebody at NASA did send me a very, very rough indication that the committee was sympathetic. They were very interested. but they couldn't make up their minds until Obama made it up for them. That's interesting. Now, in his later years, he remained as focused on space as ever. Here is a picture of Deborah and George in Huntsville at the museum there. And this is a, I don't know what you call it, a display with a human in it. And that's Bernard von Braun. And George was absolutely enamored by him as a child because of the Collier series and various other things. And he was finally experiencing von Braun in person. And as you can see, it's quite a display. Has anybody seen that? Because I was in Huntsville and never saw it. Maybe it came down or something. Who knows? So thank you very much for attending. I have a lot of people to thank. I've had to give away most of the books that I got to the people who I interviewed and the archives that I use. And the wonderful people there, you may recognize some of their names. Well, there's Angel Callahan, but Harry Heckathorn, Meyer, Englert, R. Conway, those are all NRL people. Giovanni, Russell Howard, Kautha, and so on and so forth. So it was, and including former students, Patrick, Callany, and Glasgow. They all submitted to oral histories. A few of them are not printable, and nothing to do with George, but it was an interesting experience. And there's George in later life applauding. Now, there is one of the AI renditions of him looking through the soda bottle. And tell me who did the AI? I said it.
Alan Janus.
And Alan Janus, thank you very much. I put it there, that it's Alan Janus, and I think we miss it very much, terribly much. I don't know, did anybody else know Alan Janus? Yep. He really got into AI, and every day you would see something outrageous on the web. Wonderful, wonderful guy. Okay, so from the laboratory to the moon, you can take the flyer that I brought here, and if you have any questions, I mean, we can talk here. This is mainly for the virtual thing. Just email me at DeVorkin@FI.edu. If you have questions that you don't want to admit having, you can email me. I think that's the last one. Yep, thank you.
Do we have any questions online before you go to or
I was thinking you might show the Carruthers image from the moon of the hydrogen geocorona that extends way out. Do you have that image?
Well, those are the ones that I have. What one are you talking about?
One that shows the hydrogen gets way larger than the Earth because it goes out much further.
I've not seen that one. I'd love to see it.
Try to find it on.
Okay.
box?
Yeah.
So the original camera is still on at the Apollo.
Yeah, what's
6
left
site.
of it? Yeah, I mean, it was.
They just brought the film camera.
That's right. And, you know, and there's a question, how much of it is left after the craft, you know?
Yeah, after it took off.
Oh, it's right next to the limb.
It's right next to the limb.
Yeah.
There's one LRO image that I found that has a little spot next to the lander, the legs. And I would love it if that was Carruthers. I mean, I'd like to, if we ever get back to the moon, one of my goals would be to try to convince the powers that need to turn it into a little memorial.
Other questions here?
By the way, I have a copy of the book if anyone wants to take a look at it.
Oh, okay, that's great.
You get an autograph.
Autograph.
I'm looking at the chat. I'm not seeing any questions. Do we have any questions online?
No.
Okay, no. Okay, well, sir, thank you again very much for this very interesting presentation and all the information, and the handouts are right there. As I said, we're going to have dinner at our George across the way after
What's the
this.
name of the restaurant again?
Say again?
What's the name of it?
Oh, George.
Oh, George.
Yeah, I don't think there's too many restaurants named George over there, but it's Oh George to do it correctly. If we don't have anything else today, well, thank you very much online and those of you here, and we'll see you out there. And we appreciate everything you do for the club, and we'll see some of you over at Old George. Thank you. Have a good evening.